So for number 1, we're trying to find the region bounded by the x-axis, this parabola y equals x squared plus 1, x equals negative 1, and x equals 1. So this whole highlighted region is going to be revolved about the x-axis. So we're spinning that whole thing around the x-axis. And you can see kind of a portion of that here, it's kind of cut out. But it looks like a big kind of spool, almost. Like you would have like a spool of thread. So here we're going around the x-axis, and we have a dx cut. So it means everything's going to be in terms of x. So as we spin that, and you can kind of see the cylinder over here, if we take this rectangle and spin it around, we get this little disc. The radius is right here. Right? That vertical distance. This right here would be our radius. Well, that vertical distance from the x-axis up to the graph, that's really just like the y value. Right? The radius is the y value of this graph. But, like I said before, this is going to be a dx cut. It means the integral we set up, everything has to be in terms of x. So I can't just put y squared in there for my radius squared. I'm going to have to put in what y is equal to in terms of x. And we know that from the equation. Y is x squared plus 1. So that's our radius. So when we set up our integral, it's pi times the radius squared times the height. Well, the pi part, I'm going to put that out in front, because remember, with constants, we can pull that out in front of the integral. The radius is x squared plus 1, so that's going to be squared, times the height of the cylinder, that's going to be the dx. All right, the height of the cylinder is dx. For discs, the height's always going to be dx or dy, depending on which cut we're using. Radius is always going to be the function in terms of either x or y, depending on what we're doing. What's our lowest x value here for this interval, for this region? Negative 1, right? And then we're going up to positive 1. So we can evaluate this integral in our calculator. So notice the pi is out in front. We can leave it that way. That way we can get an exact answer if we need to. So math 9, and we've got parentheses x squared plus 1, close the parentheses, squared, comma x, comma negative 1, comma 1. And we get 3.73 repeating, but we can change that into a fraction. And we get 56 over 15. So we get 56 over 15 times pi. Right? If this were a multiple choice question, you might have to give an answer that's exact. So you would want to be able to do that. If you put the pi inside the integral, it's not going to be exact. But you may also have to give a decimal approximation, so we can just take that answer and multiply it by pi. So we get 11.729. So for your response, I would accept either one of these, but I'm just showing you in case you needed to. It doesn't hurt to have that pi out in front. And a lot of times when there might be problems where it just asks you to write the definite integral. You don't have to actually calculate the volume. It'll ask you to write the integral. You can leave the pi inside, outside. It really doesn't matter.